Good morning. Today we're going to be reviewing for the exponential functions unit test. So you should be watching this video and copying the work onto either the Jamboard or a piece of paper because you will be turning it in for a classwork assignment. So let's get started. The first one is simplifying the following expressions. So these are our exponent rules. Remember, when we're multiplying, we add the exponents. When we're dividing, we subtract the exponents. So here we are multiplying. So we want to take the coefficients, which are -3 and 7, and we want to multiply those to give me -21. And then my x values are x times x squared. Remember, if there is no exponent, you can write a 1 in. So 1 plus 2 is 3. And then we have y cubed times y cubed gives me y to the power of 6 because, again, we're adding the exponents. Next, we have 10x cubed, y to the 4th, over 25, x to the 7th, y. So we're going to do the same thing. We're going to focus on the coefficients. We can only simplify them to be, we can divide each one by 5. So we get 2 over 5. And then we have x cubed divided by x to the 7th, which really means you're subtracting them. So 3 minus 7 gives me -4. So we have x to the -4th. And then I have y to the 4th divided by y to the 1st, which gives me y cubed. We also talked about negative exponents. So if there is a negative exponent, which we have right here, we want to make it positive by either moving it to the denominator or the numerator. It depends where it is. It's in the numerator right now, so we want to move it to the denominator. So 2 and y cubed will stay the same. 5 is going to still stay in the denominator as well, and then x to the -4th is going to go to the denominator to be x to the positive power of 4. So this will be my final answer here. Remember, you're only moving terms if they have a negative exponent, not if it's a negative number. Okay, so if it's a negative, like say in the first one, we have -21, you're going to leave that right there. Okay, only if there's a negative exponent, you want to move it to the denominator. Okay, then we had power to a power rule, which means if you have a power to a power, that means you're multiplying. So first we have 2. This cubed is going to go on each of these terms. So 2 cubed, and then we have x to the 4th to the power of 3. So we can simplify this. 2 cubed is 8. And then x to the power of 4 raised to the power of 3. You're going to multiply those and get 12. So we have 8x to the power of 12. Next, we have 18x to the 4th, y squared, over 3x to the 8th, y to the 5th. So we're going to focus on the coefficients. 18 divided by 3 is 6. Now we're going to focus on the x values. We are dividing, so that means we're subtracting. 4 minus 8 gives me -4. And then my y values, 2 minus 5 gives me -3. But again, I don't want negative exponents. So that means 6 is going to stay in the numerator, and we're going to move x to the 4th, y to the 3rd, down to the denominator because those have the negative exponents. So this here would be our final answer. All right, next it says the population of Nottingham High School is modeled by the equation where t represents the number of years since 2000. Is the population increasing or decreasing? Well, we have to look at this number here, and it looked like it went down from 100%. So that means if this number is in between 0 and 1, that means it's decreasing. If that number is 1 or is bigger than 1, then it's increasing. But right now, it's less, so it's decreasing. What is the percentage that it is increasing or decreasing? So you always have this right here. We know it's decreasing. It was really, we started at 1, or 100%, and we had to subtract a certain percentage to get to this 96%. So 100 minus 4% gives me 96. So the percentage that it is increasing or decreasing is by 4%. Last, it says, what will be the population after 15 years? Round to the nearest whole number. So remember, t represents time. So after 15 years, we're going to plug in a 15 into this equation. Okay, and this is where we're going to use our calculator. So I have 2,600 times 0.96 to the power of 15. And it says to round to the nearest whole number. So this 4 in this spot is not going to be big enough to make this 9 go up. So it's going to stay 1409. So that would be the population after 15 years. Number 4, bacteria can multiply at an alarming rate when each bacteria splits into 2 new cells, thus doubling. We start with 1 bacteria that can double every hour. Write an exponential function to represent this situation. So this is where we have f of x equals a times b to the power of x. Anytime we don't have a percentage, we're going to use this formula. Remember, a is the initial amount, and b is the number that's it being multiplied by. Okay, that's the multiplying factor. Okay, and then x represents time. So, where is it starting? It's starting with 1 bacteria. And then we're multiplying by b, which is the multiplying factor. Well, it says it can double every hour. Doubling means you're multiplying by 2. And then we have to the power of x. So multiplying by 1 here doesn't make a difference, so we could just say 2 to the power of x. And how many people will know? Oh, that was supposed to be for another example. Sorry about that. So this should read, how many bacteria will there be after 15 hours? So don't mind this part. How many bacteria will there be after 15 hours? So we're going to take our equation that we set up and we're going to plug in 15. So 2 to the power of 15. And we get 32,768. 768. Okay, so that's how many bacteria there will be after 15 hours. Don't forget, we should be copying this down, so you turn it in for a classwork assignment. Number 5, the number of bacteria in a lab experiment is increasing by 2.5% per year. The experiment started with 200 bacteria. Write an exponential function that models the number of bacteria, y, as a function of the time in years it's been growing by x. Okay, so this is where we're going to use the formula y equals a times 1 plus or minus r to the power of t, or it could be to the power of x. but it just represents time, okay? So we're going to use the plus or minus in there depending if we're increasing or decreasing. In this case, we are increasing, so we will be using the plus sign. And A, again, is where it starts off, and R is our rate or our percentage as a decimal. So we have Y equals, it's starting off with 200 bacteria, and then we have 1, since it says increasing, we're going to add 2.5%, but again, we're going to change that to a decimal by moving the decimal point 2 places to the left. So it becomes 0.025 to the power of t. So we can simplify this a little bit, or you can leave it as it is, but we'll have 200 times 1.025 to the power of t. So now it's asking how many bacteria to the nearest whole number will be present after 8 years. So we want to plug in, we want t to be equal to 8. So we have 200 times 1.025 to the power of 8. 200 times 1.025 to the power of 8. And it says to round to the nearest whole number if necessary. So 243 is the whole number, but we have to look one next door. It is a 6, which makes it big enough to make this whole number go up to 244. So after 8 years, there will be 244 bacteria. Number 6, create a table of the values and graph the following. So we have an exponential function. I know it's exponential because I have the exponent is a variable. We have 8 times 2 to the power of x. So this, I'm just going to come to my graphing calculator, and I'm going to graph it in there. So 8 times 2 to the power of x. I'm going to pull my table, and here are some numbers. Okay, it's looking like -2 is right here. I want to get another nice number. Maybe I can get -3 in there as well. So I have -3, 1. It doesn't look like any of the other numbers will be nice numbers. Maybe -4 I could try. It is 0.5, so that's not bad. It's right in between. So you're going to pick a few of these numbers from this graph, and you're going to just copy it onto your paper. So we're going to start with -4 and maybe just go up to 0. Okay, we want to have enough there so we can see that curve. So I have -4 and 0.5. And I'm going to do -3, -2, 1, -1, and 0. So I have 1, 2, 4. And then 0 is 8. So you must, if it says to create a table of values, you must write this down. Don't skip that step. So I'm going to zoom in a little bit. It's a little bit easier to graph. So I have -4, 0.5, -3, 1, -2, 2, -1, 4, and then I have 0, 8, which is here. So there's my points, and then I'm going to just draw a nice curve, and on each side, I'm going to make sure I put the arrows. So this is what you should have on here to get full credit. Copy the table, plot some points, and then draw the graph as accurately as possible. I know it's not going to be perfect. This is most certainly not, but it's close to what this looks like. All right, number 7, determine if the function is exponential or linear. Then write the equation. So if it is exponential, you're multiplying by a certain number. If it is linear, you're adding by a certain number. So we have to look at the pattern here. So I have 4 to 12 to 36 to 108. So I can see 4 times 3 gets me 12. 12 times 3 gets me 36, and so on. I notice that I'm multiplying by 3. Therefore, it is exponential. Okay? And that exponential function is that standard form, which is y equals a times b to the power of x. And remember, a is where is the, oh my gosh, I can't think of the word, is the y-intercept. A is the y-intercept. So that's whenever x is equal to 0, so here, x is equal to 0 here, that means the y-intercept is 4. That's what a will be. So it's y equals 4 times b. And b is our multiplying factor. Well, we are multiplying by 3 each time. And then this x is always going to stay x. So I have y equals 4 times 3 to the power of x. That's my equation. Okay, and again, I always use this standard form of the exponential function. Okay, we have another one. Is it exponential or is it linear? And then we're writing the equation. So to go from 11 to 8 to 5 to 2, we have to figure out what the pattern is. And it looks like we are subtracting by 3 each time. Okay, so since we are subtracting, or you can say adding a negative, it is linear. I don't know why it's not writing on there now. But the linear function, the format is y. Come on, why are you not writing? Guess I just have to give it a second to load. So the equation, remember, is y equals mx plus b. Let's see if I could type. Okay, I'll type it in. Y equals mx plus b. So b is our y-intercept. Our y-intercept is where x is 0, so we're going to plug in a 5 there. And m is going to be what we're adding or subtracting by. So our final equation is y equals negative 3x plus 5. And number 9, a geometric sequence is defined by the following. So a of 1, which means the first term in the sequence, is 16. And the sequence is defined by a of n equals a n minus 1 times 1/2. So we want to write out the first 4 terms of this sequence. Okay, well, the first term, I have to continue writing. So the first term was 16. The second term is going to be, well, we want to take the term from before. That's what this a sub n minus 1 means. You're going to take 16 and you're going to multiply it by 1/2. So half of 16 is 8. A of 3, same thing. We're going to take the term from before, which was 8. And again, we're multiplying by 1/2. 1/2 of 8 is 4. And last, We take the term from before, which was 4, and we multiply by 1/2, which gives me 2. So the first 4 terms are 16, 8, 4, and 2. Remember, geometric sequence means you're multiplying by a number. Okay, so that is it for the review. If you have a good understanding of what we went over today, then you will do just fine on the test tomorrow. The test, I'm telling you, looks very similar to this review. So if you have any questions about this review, or you just need a little bit of extra help on a certain question, please reach out and let me know. And tomorrow we'll be taking the test.